This video looks at a new Mplab X Ide tool that helps you generate the files needed to implement a CI/CD pipeline for rapid delivery of reliable products. There are many challenges teams face when developing complex software. Repositories and revision control systems solve some of these, but a means of testing code changes in a timely and reliable way is paramount to a project's success. To be effective, testing should be automatic and initiated immediately after code is committed, while changes are still fresh in developers' minds and before any consequences can affect other team members. It should also be conducted within an environment that is consistent with that used to build the final production image. By continually testing incremental changes in source code and immediately addressing any arising issues, teams can realize a continuous delivery of a reliable product, an operating principle known as continuous integration, continuous delivery, or CI/CD. Let's look at an example of how a CI/CD pipeline might be implemented on a test machine. A source code management system, like Git, is in place. Checked into the repository is the project being developed. To coordinate the jobs associated with the pipeline, a Jenkins automation server has been installed. Such servers can be run on the test machine itself, but are often installed externally, with the test machine hosting just an agent. A Jenkinsfile is a script that defines a Jenkins pipeline, and such a file has been checked into the repository along with the project. The pipeline will run a Docker virtual container to ensure a consistent build and test environment. A Dockerfile, which defines the steps needed to create an image that can be run as a virtual container, has been checked into the repository. This will be executed by a Docker client installed on the test machine. Scripts used for source code compliance, code coverage analysis, and testing have also been checked into the repository. Let's now look at how all these components work together as the project is developed. On a developer's machine, a change to source code is committed to the repository. The developers continue work, but a job associated with this project on the Jenkins server is regularly polling the repository looking for any changes. When detected, the Jenkins agent on the test machine is instructed to begin the pipeline. The Jenkins agent will check out a copy of the repository on the test machine, open the Jenkins file, and begin executing the stages of the pipeline. Following the instructions in the Docker file, a Docker image is created based on a Debian image and extended with the applications needed to build and test the project, such as the Mplab X Ide, compiler, license information, device family packs, and other tools. This image is then run as a container, on which the checked out project volume is mounted. Within the container, the project is built, then the project artifacts are packaged and made accessible through the Jenkins server interface. Testing of the project takes place in accordance with the defined scripts, with the results also accessible from the Jenkins interface. A CI/CD pipeline such as this meets many testing requirements, and the Mplab X Ide's CI/CD wizard can assist you by creating the Jenkins file, Dockerfile, and the test and analysis scripts needed for its implementation. Here's how to use the CI/CD wizard to create the files needed to implement a CI/CD pipeline. Run the Mplab X Ide. This doesn't have to be on the test machine. Ensure your project is open and verify the project properties associated with the relevant project configurations. From the menus, select Tools, CI/CD Wizard, and work through the dialogues. Select Jenkins pipeline files to create both the Jenkins file and Docker file. Select Dockerfile to create only a Docker file. If a compiler license has not been detected, a product link and license configuration button will also appear here. Select the IDE version to be installed in the Docker image and that will be used for building and testing, and select the project configuration to build. As the compiler will be running in a container, you must have a network server license to allow the pipeline to build with Pro-only optimizations. Although for testing purposes, you can generate all the pipeline files with just a workstation license. Enter the URL and port number for your network server license here. You can confirm the details using the test button. You may have more than one Jenkins agent available, so labels are used to indicate which agents are permitted to run the pipeline. Labels are assigned to agents from the Jenkins server dashboard. The Docker host agent label further refines which Jenkins agents should run pipeline stages that require Docker. The Debian Docker image, on which your image will be built, is obtained from a default Docker registry. If you want to specify an alternate registry, select the checkbox and enter those details here. Your source code can be checked for compliance with the MISRA rule set. If you have an Mplab Analysis Tool Suite license, select the checkbox to have these checks added to the pipeline. Choose the best way to have the results reported, ensuring that the relevant plugin is installed in Jenkins. Select the Enable Simulator Testing checkbox to have testing conducted in the simulator. You can select an alternate project configuration for the testing stage if required. If you select Enable Simulator Code Coverage, the simulator's code coverage feature will monitor which instructions have executed to indicate the extent to which your project's source code has been verified. The Code Coverage API plugin must be available on the Jenkins server to display the results. Select the Scan Output for Unity Test Results checkbox if the project source code contains Unity test runners, whose output on the specified serial communication peripheral should form the basis of a report. You may additionally or alternatively wish to select the Enable Hardware Testing checkbox to have testing performed on your hardware through debug tools with networking capabilities, such as the Mplab ICE4. But note that a breakout board must interface the ICE4 to your hardware. Enter the IP address of your debug tool in the dialog and select any other testing features required. To use the Mplab code coverage, you must have a valid Mplab Analysis Tool Suite license, and then ensure that the compiler option to instrument the generated program image has been enabled in the project properties. Next, specify if Doxygen should be enabled as a documentation tool, what output you desire, and how it should be configured. When you click the Finish button, the resources required to configure the CI/CD pipeline will be created and saved as text files in your project. Double-click their icons in the Files view to open them in the IDE's editor. You might, for example, follow the MDB command line documentation to edit the MDB script to customize how testing should be performed. The CI/CD pipeline can be enabled after committing the files generated by the wizard. If you need assistance or experience issues with the execution of these files in third-party tools like Jenkins or Docker, ensure you contact the organization responsible for these products. Full details about the prerequisites, setup, and operation of CI/CD pipelines created using this tool can be found in the CI/CD wizard in Mplab X Ide User's Guide. Continuous monitoring and automation at the integration and testing phases of project development is key to delivering a reliable product in a timely manner. A CI/CD pipeline using virtual containers is an effective way to achieve this, and the Mplab X Ide CI/CD wizard can help you generate many of the files needed to implement such a scheme.